Section 6, question 5. Find the solutions of the equation sin squared p minus sin p plus 1 equals cos squared p between pi over 2 and pi for p. Okay, so I'm going to first of all bring that across, change sign, and I'll get cos squared p minus sin squared p is equal to minus sin p plus 1. I'm going to bring that stuff across and just make everything equal to 0 now. So I've got cos squared p minus sin squared p plus sin p minus 1 is equal to 0. I can then use the double angle formula, this one that you seldom use, but cos squared p minus sin squared p is one of the expansions for cos 2p, so I could say that's cos 2p plus sin p minus 1 is equal to 0. I can then use cos 2p equals 1 minus 2 sin squared p plus sin p minus 1 is equal to 0. Right, so that'll be minus 2 sin squared p plus sin p, and the 1 and the minus 1 will cancel out, and that gives me 0. I'm now going to take out a common factor of sin p, so that'll be sin p bracket minus 2 sin p plus 1 is equal to 0. So on this side I've got sin p equals 0, and this side minus sin 2p plus 1 is equal to 0. P equals sin inverse 0. So I'm in the all quadrant and the sin quadrant. So the all quadrant solution is 0, and pi over 2 for the sin quadrant. So both of these don't lie within the limits, which is between pi over 2 and pi, but not including pi over 2 or pi. So they're not solutions that I'm looking at. So let's see if I can get any solutions from over here. So bring that over, and that'll be minus 2 sin p equals minus 1. I'm now going to divide through by minus 2, and that's sin p equals minus 1 over minus 2, and that will be sin p equals 1/2. Build my cast diagram. I'm in the all quadrant and the sin quadrant. P equals sin inverse 1/2, and that's 30 degrees, but in radians that's pi over 6. And in the sin quadrant that will be pi minus pi over 6, so pizza take away 6 for pizza gives me 5/6 for pizza. Pi over 6 isn't within range either, so my final answer to the question is 5 pi over 6, and that's the only solution. Section 6, question 6. Express 5 sin x minus 12 cos x in the form k sin x minus a. That's part A. Part B is then hence solve the equation 5 sin x minus 12 cos x equals 6.5. So I'm going to first of all tackle part A. So it's just a straightforward wave function. 5 sin x minus 12 cos x is equal to k sin x minus a. So 5 sin x minus 12 cos x is equal to k bracket. So the sin minus expansion is sin cos minus cos sin. So that's sin x cos a minus cos x sin a, close the bracket. It's 5 sin x minus 12 cos x. I'm going to just flip them round as I open up the bracket, so that's k cos a sin x minus k sin a cos x. So the coefficient in front of sin x is 5, Coefficient in front of sin x is k cos a. So k cos a is equal to 5. Coefficient of cos x is minus 12. Coefficient of cos x is minus k sin a. So minus k sin a is equal to minus 12, which obviously means that k sin a is equal to plus 12. So I've got k sin a equals 12, k cos a is equal to 5. Divide one by the other, so k over k goes, sin over cos is tan, and I've got tan a equals 12 over 5. So at this point I can put up the cast diagram. So sin is positive, all in sin, and cos is positive, all in cos. 2 ticks in all quadrants, so that's what I am. So a equals tan inverse 12 over 5, and that's 67.4 degrees. I'm now going to find my value for k. So it's square root of 12 squared plus 5 squared, and it's square root of 169, and it's 13. So the wave function then is given by 13 sin x minus 67.4, and that's part A. Part B is now asking for me to solve the equation 5 sin x minus 12 cos x equals 6.5. So hence means I take the result from up above. So that's been now written as 13 sin x minus 67.4, and I'm going to make that equal to 6.5. I'm going to then bring the 13 down, divide, and that will give me sin x minus 67.4 is equal to 1/2. I'm going to also adjust the limits, so the lower limit now becomes minus 67.4, and the upper limit will now be 67.4 of 360, and that's 292.6. So x minus 67.4 is equal to sin inverse 1/2, and I'll put up the cast diagram. I'm going to bin that all in the same quadrant. So x minus 67.4, so sin inverse 1/2, that's 30 degrees. In the sine quadrant, that will be 180, take away 30 degrees, so it's 150. I'm now going to bring 67.4, minus 67.4 across, and that will give me 97.4 and 217.4 degrees. If I add 360 onto either of those, or subtract 360, I'll be out with my limits. So that's my final answer to the question.